Our first presenter is Goran Zlodi from the University of Zagreb, the Faculty of Humanities and Social Science here in Croatia, where of course we were supposed to be if COVID hadn't had other ideas. So Goran will be presenting with his, he will be presenting on behalf of his co-author Tomislav Ivanico, Approaches to Collaborative Multilingual Thesauri Development in an Educational Context. So please, Goran, over to you.
Good afternoon to everyone. My name is Goran Zlodi, and I would like to present you a project coordinated by my colleague Tomislav Ivanico and me. Project is about collaborative multilingual thesauri development in educational context. So we developed specifically model of collaborative terminology contribution to the art and architecture thesaurus, the most important multilingual vocabulary resource for art and cultural heritage. The project is started and coordinated at University of Zagreb, Faculty of Humanities and Social Sciences during last academic year. And it has been implemented through the collaboration of academics, museum professionals, and students to start and accelerate translation of AAT in Croatian, and at the same time to enable students to learn about terminology and and thesauri from real life examples. So let me tell you a few words about art and architecture thesaurus. AAT is part of the Getty vocabularies. It contains multilingual structured terminology to describe visual art, architecture, archaeology, archival materials, visual surrogates, and so on. It is available in open access as linked open data, so it is crucial for achieving global interoperability. AAT is multilingual, so it is very important for availability and visibility of cultural heritage. For example, it makes possible to metadata entered in one language, Croatian, Serbian, Hungarian, can be searched and displayed not only in English, but in all other languages included in AAT by mapping process. And now large translation projects are currently underway worldwide. But there are also some challenges. Terminology contribution and translation projects require the engagement of experts, some financial and organizational resources. So there is one possible solution: engagement of students through the modification of different methods from crowdsourcing projects, like motivation, quality control, and so on. But it is necessary to be aware that we are in an educational context. Neither our students are a crowd, nor is the point in using students to just do some work. So a possible solution is academic crowdsourcing, or how we like to call it, edusourcing. In our model, there are two major groups of participants, experts and students. In the expert group, there are museum professionals from several museums, university professors, and among students attending the course documentation in museums. They are double major students, information science museology as one subject, and one of the humanities or language subjects as other. So there are student group 1, in which are all 20 participants of course, and student group 2 as a special group of 5 students, volunteers, who invest their free time in the project. The process of translating terminology and building thesaurus is an interdisciplinary work, and the following experts are needed: content experts, language, thesaurus, technical experts, and project coordinators. Therefore, expert roles are assigned to the participants as follows: obviously to experts in the particular fields, and to students according their subjects. Here is the workflow developed harmonized by AAT guidelines for translation projects, but also by methods of academic crowdsourcing. So in the first stage, we decided to choose terms from the following domains: materials, techniques, styles and periods, object names, and author roles, all key metadata categories for description. From domains above, the 2,000 most frequently used terms were selected from the partner institutions' databases. So I would like to emphasize here that this is the most common terminology, which it would be desirable for students to know, not some special terminology, for example, like classical architecture, which would require different approach. In the second stage, the selection of scholarly sources and general reference works was carried out through analysis of required and optional literature and to the further consultations with experts. In the third stage, that is carried out by all 20 students at the course, the following steps have been taken. Each individual Croatian term is searched in the following online encyclopedias. Scope notes from AAT are translated into Croatian, and AAT definitions are compared with definitions from sources. So finally, mapping and linking Croatian terms to AAT was made via Sparkle or manually. In the fourth stage, students of Special Group 2 carried out selected literature research, while first group consults only online sources, second group, volunteers, consult also extensive printed material. Then students documented and cited references and definitions. They proof-checked the mapping that student group 1 had worked on. And finally, they categorized errors, if any. For example, in Thesauri, mapping of concepts with slightly different scopes, broader or narrower, are not allowed. In the fifth stage, which was carried out by experts, only the terms that students categorized as particularly demanding were given for translation to the expert. So this saved time for experts. After review and verification of all terms, more than 500 terms have been designated as suitable for export to AAT. In our project, we mapped cognitive domains of edusourcing in terminology development according to Bloom's taxonomy. And here is our attempt to map it to the scholarly primitives. So please check our presentation at Zenodo platform. So maybe you can find some interesting inspiration. And I have to conclude that further research is also needed because we want to utilize and improve our model. We want to know how to improve translations and the quality control. For example, we want to know what terms from which domains to assign to students from which study group. And to what extent is student engagement acceptable? For example, in some special terminology, it would be needed some kind of adjustment of model. And here are some conclusions. The proposed collaborative model can facilitate the contribution of terms to multilingual thesaurus and ensure the quality of the process. And at the same time, students can reach desired learning outcomes on real-life projects. What is really important, some concrete results, the new multilingual terminology is available to everyone, to machines, but also to humans, for reuse through linked open data. So it will, so availability and visibility of cultural heritage would be increased. So thank you for your attention. I would be happy to answer on your question. Thank you.
Thank you very much indeed. So let's give a virtual round of applause to Goran for this perfectly timed, very clear explanation. So thanks very much. Brilliant. So that was a great start. So now I would very much like to present our second group of presenters in this session. That is Simon Sendler, Daniela Schulz, Hanna-Lena Mayens, and Bernard Fisenni. And I think Simon Sendler will be presenting. They're from the Göttingen State and University Library in Germany, the Herzog August Bibliothek in Wolfenbüttel, also in Germany, and the Leibniz Institute for the Deutsche Sprache in Mannheim. And Simon, who will be presenting today, will be talking about the criteria for recording and categorizing of scholarly digital editions. So Simon, if you would like to share your presentation.
Yes, today I will be talking about criteria for recording and categorizing scholarly digital editions. This is a result of the project DARIAH-EU, which has been harmonizing the developments of the digital research infrastructure projects Clarin-D and DARIAH-D since 2019 to make the established structures of these two projects interoperable. Due to its focus on language and text-based research data, one important step towards DARIAH's goal of comprehensive interoperable research infrastructure is to evaluate which representations are adequate for different kinds of data and data processing. As a significant part of the concerned repositories encompass largely scholarly digital editions, standards for the creation of and work with these texts are of special interest to DARIAH. In the terminology of the FAIR principles, this presents an important step of making editions findable, accessible, interoperable, and reusable. Or, bearing with the topic of the conference, we aim to aid the discovery and selection, the sampling and comparison of editions. As our chief concern is the reuse of data, I will begin with some general remarks on the topic of data sustainability. Then I will discuss the categories and criteria we found most useful working with editions. Afterwards, I will briefly talk about the ways we intend to make our results accessible to the larger community. And then I will end with a short conclusion. Experience shows that within the field of digital editions, two important concerns can sometimes conflict: expressivity of markup and interoperability. This observation is at the heart of our considerations. On the one hand, scholars desire a data model representing their source as precisely and efficiently as possible. To achieve this, the guidelines of the TEI, the most common standard for digital editions, offer multiple markup options for the same or similar phenomena. A preference between two possibilities of encoding might arise from the markup itself or from considerations beyond the XML document, like intended further transformations or workflows of the project. I've brought a little excerpt from the preface of the TEI guidelines illustrating their broad scope. One central phrase here is "without restriction on form or content." This broad scope is great for editions, as the TEI offers projects the possibility to create an encoding scheme that is finely tuned to the demands of a project subject. On the other hand, interoperability of data is crucial to its sustainability and reuse. TI data, while, as the title of the guidelines suggests, is intended to be perfectly interchangeable, rapidly loses interoperability the more complex the markup gets and the more decisions for specific alternatives diverge. Non-interoperable data is unlikely to be used beyond the scope of the project it originates from, resulting in what is sometimes called a data or information silo. The distinction between interoperability and interchangeability is important to keep in mind. Interoperability generally refers to data exchange with little to no human initiative involved. One way to facilitate the use of research data is to provide the data in a pivot format as well as its native format. Pivot formats are derivative formats that may not represent an object in the same depth and detail as an edition's native format, but still provide a core body of data about the encoded text. One benefit of established pivot formats is that there are existing digital research tools that are prepared to handle these formats without any need to adjust the markup. Edition data converted to a pivot format is also more easily integrated into corpora demanding homogeneous data, increasing the visibility of the edition. As I said, Native formats of editions can be quite complex, and the effort for transformation into a pivot format increases accordingly. Even trying to convert a small sample of editions, we faced a number of questions. Can we identify features of editions that generally impact the complexity of conversion? Can we establish a workflow for such conversions? How can we make our insights usable for the broader community? We hope to present a way to provide at least a measure of comparability between the different and diverse native formats of editions, as well as offer some assistance to scholars wishing to convert their own edition data into a pivot format. We decided that the German text archive base format would be the pivot format of choice, as one of DARIAH's partners is involved in the development of the standard, as well as the fact that the base format is relatively well known and used as a standard beyond the text archive itself in Germany. To assess the suitability of a format to serve as a pivot format for a range of editions, some methods of categorizing editions is needed, creating a frame of reference for comparing editions. We have developed an edition matrix, which allows us to choose editions as diverse as possible in subject matter and markup complexity as exemplary candidates for conversion. Based on relevant scholarship and an informal assessment of editions produced at our home institutions, we arrived at 7 categories to discern central features common to editions and to gauge an edition's complexity. These are the editorial model, the markup, the discipline, the epoch, the type and transmission of the material, the language of the base material, and the number of documents to be encoded. The editorial model is a central feature of any edition. Trying to achieve a compromise between our desire to make editions comparable and the significant diversity of the field, we have identified 7 basic editorial models that you can see here. These models are not exclusive. An edition might follow more than one model. The markup determines which phenomena found in the text are encoded. As a frame of reference, the criteria in this category are broadly modeled on individual modules of the TEI guidelines. Our assumption is that, in general, more modules being used lead to more complex transformations, as simply more elements and more phenomena have to be considered. Furthermore, individual modules, such as the module text grid, go beyond the scope and functionality of our pivot format, so the use of these modules is bound to increase complexity. Discipline and epoch. The scholarly discipline and the epoch might not have a direct influence on the complexity of the transformation. One might expect some general trends, however, our still rather smallish data set cannot support this. Maybe not yet, well, we'll see. More importantly, information on discipline and epoch provides a way to cross-reference similar editions and investigate cluster of similar editions. The 5th category refers to the materiality of the witnesses containing the edited work. Is there more than one witness? Are the witnesses in manuscript or print? And more. Because of the possible diversity of transmission, it is possible to select several criteria here. The same applies to the language or languages of the base material. The number of documents itself is not necessarily an indicator of a more complex transformation. If the markup is coherent and consistent, a larger number of relatively uniform documents does not affect a more complex transformation. Yet in combination with other categories, for example, a rather diverse transmission or a demanding editorial model, the number of documents might have an impact on the complexity of the transformation. Otherwise, this is relevant information for cross-referencing editions. So these are the categories we want to use to gauge an edition's complexity. Of course, you could simply make a spreadsheet and fill it in, ticking off boxes if criteria are met, but that wouldn't be very accessible. That is why we try to implement these categories into a survey. To provide an accessible approach to our matrix, we are developing an online questionnaire using the open source software Lime Survey. Users can consult this questionnaire to estimate the complexity of transforming a given edition's native XML into a basic exchange format to facilitate interoperability. After filling out the questionnaire, users receive some basic recommendations regarding the transformation. As these are ultimately highly dependent on the project and require individual adjustment, users also receive contact information for further advice and feedback, as well as some references to relevant literature. how we measure complexity is not yet finalized. Early on, we tried implementing a simple point score approach. The more boxes you tick off, the more complex your transformation is likely. Of course, this did present several problems, such as the fact that counterintuitively, an addition encompassing a large number of relatively basic transcription would net a higher score of complexity than a critical addition covering only 2 or 3 textual witnesses. Currently, we expect that some categories will be more informational than functional, meaning that they will play a role in cross-referencing additions, but not in a sort of complexity score. I will now present a few preliminary results of our matrix and survey. As you can see on the bottom right, this is a rather smallish data set of about 40 editions from the home institution of my colleague Daniela, but they might already give an idea of the kind of data we can expect, and maybe even how the data we collect might help in modeling the diverse field of digital editions. Considering the time, I don't think I can spend too much time on these graphs. Personally, I think it is interesting to note that the historical critical edition and transcription are the most common models used across disciplines. And as you can see here, the addition of multiple print witnesses is prevalent in most fields present in our sample. I think this focus might hold when our data sample grows. The prevalence of convolutes and single manuscript might be due to the inventory of the Wolfenbüttel library, where this data is from, but this also might hold. Now, one might ask, why the effort? Why not use a pivot format from the get-go if interoperability is the goal? The short answer to this is, again, expressiveness. Truly interoperable data offers a breadth of possibilities for scholarship, but it often constricts the oppressiveness of markup. Pivot formats are usually developed for specific applications or to provide a sort of lowest common denominator. As our conclusion is to recommend offering textual data in its native format and a pivot format, one consequence is to try to keep to a minimum the effort needed for a conversion into the pivot format. Our working group is currently drafting a recommendation for creating native formats that are easily convertible into our pivot format without restricting the expressiveness of the markup. Finally, we try to give recommendations that are applicable as broadly as possible. Every transformation still will be unique in its own way. Scholars will always face judgment calls on which features of an edition are essential and need to be reproduced within the confines of the pivot format, and which markup can be simplified or outright ignored during conversion without losing information central to the encoded text. Thank you for your attention.
Thank you very much, Simon, for presenting on behalf of your colleagues. And that is fascinating to hear the interrelationship between expressivity, interoperability, which isn't equal to interchangeability, and then the complexity of it also. Thank you very much indeed. And now we're already at our third and final presentation, but last but not least in this case for this session. So I'm delighted to welcome André Kilchenmann and Flavie Lorenz, who both work at the Data and Service Center for Humanities, or DaSCH, in Basel in Switzerland. And I don't know how many of you know, but Switzerland yesterday became the first observer in DARIAH-EU, and DaSCH is leading all the scientific activities in their area. So congratulations to our Swiss colleagues. And today they will be talking, and excuse me for my bad Latin pronunciation, Unus pro omnibus, generic research tool for all the humanities disciplines. So thank you very much. Over to André and Flavie.
In the next 10 minutes, we explain what this means, and we want to present who we are, what we do, and how we do it. So let's start. The Data and Service Center for the Humanities, or short DaSCH, is a national research infrastructure in Switzerland, which provides data handling services like data curation, long-term access, and research and analysis tools to work with qualitative research data, according to the open research data and FAIR principles in the humanities. Our mission is to develop an application that fulfills all these requirements and to support a wide variety of data models, and media form from different disciplines. Our story begins many years ago at the Digital Humanities Lab at the University of Basel, and with a cooperation with the Institute of Art History. The project was about early prints in Basel called Incunabula Basiliensis. The goal was to connect various books from different libraries to compare pages and to annotate the pages, but also the metadata. So we developed a software tool, a database, and so on. The idea was similar to the analog equivalent of Mnemosyne, an atlas of illustrations made by I.B. Warburg, 1927. He pinned nearly 1,000 pictures from books, magazines, newspapers, and other daily life sources. He connected the pictures and added notes. I think you know this kind of work. We can now bring the notes directly to the pictures, and from there we publish articles, books, where we add again notes. And this was the approximate idea of our first system, but in comparison, all sources are available in one software, but they could be stored at different places. Of course, other projects were interested in such a software, but all of the other projects had different interests and data models. So we have about 20 projects online now. Some they work with books, some have photographs. We heard it already this morning. We have the Bernoulli Euler online, which works with letters, with notes and mathematical formulas. We have encyclopedias and projects with photographs, but also with moving images and books and so on. So the question was, how can we provide one database for all the different data sets? The only solution at this time was to use RDF, the Resource Description Framework. Let me show you a little example on the data model from the Swiss Society of Folklore project. One of the sources is of type photograph, and we can define the data for it as a triplet. A resource has a property, in this case labeled title, which has the value alp.gnu. But we can also define resource pointers, which can have a value from another resource. In this example, photographer is connected to a resource called person. The data model can be extended, and in this project, they also have moving images along the photographs, which can be again connected with the photo itself. All those ontologies are connected in a whole-based ontology system. The ontology's resources, classes, and properties are defined as subclasses and subproperties of the base system. And this helps to implement search and annotation tools for all the different data sets. And with RDF, we have an additional advantage. We can set access permissions for each resource, but also for each property. A project administrator can define who will see or edit a certain property or resource. So all this work is done in our backend software of the whole system called DaSCH Service Platform, short DSP. We have a data handler written in Scala that provides a RESTful API and can be connected with various triple stores like Fuseki or GraphDB. In addition to this tool, we developed and maintain a known IIIF media server for all kinds of data file representation. This is called CIPI. With the API, we can build various applications, components, etc. This means that each project can have their own application, as for example, we heard it already this morning, the BOL, the Bernoulli Euler online project, has its own application. For us at the DaSCH, we have to concentrate on one main generic web application. And we will show you now what we can do already and what the goal will be in the near future. One important feature of the DaSCH service platform is the ontology editor, where a project administrator can create an own project-specific ontology, as I explained in previous slides. To create an ontology can be really complex, and we try to simplify the step in this easy-to-use ontology creator. Here you'll see a resource named photograph, where I can define the properties and name them as title, comment, or photographer. The photographer property contains a link value from the other resource called person. When this ontology is done, the user can start to create data instances or import data and can work on it. And this will now explain Flavie.
So working on data implies, among many things, browsing existing project, dataset, or data. So for that, we have three ways to search for data. We have a generic full text search where you enter a word or a phrase. We have also an advanced search where you can filter by ontology, by ontology's resource, and you can also select between 1 and 5 properties to refine your search results. And we have a more complex search called expert search, where you can write graph search queries, which is a Sparkle transformer language developed by our team. So once you submit your search query, you will get a list of search results. This search result can be also displayed as a grid, and we get back from the backend 25 results at once. But if you have more than 25 results, of course, you can go through the pagination. When you select one item of the list, you will get the detail of the selected resource. So on this resource viewer, you will have some metadata about the resource, all the properties with all the different values. And here, it's not here on the screenshot, but you will have also the attached file, the media file, such as an image, a video file, an audio file, a PDF or a text, or even a 3D file. So if the user has the right permission, he can perform different kinds of operations, such as creating a new values if it's allowed, or edit or delete a value, and you can also comment a value. And to cite your selected resource, it is possible to copy the ARC URL. So in more details about this resource file, you can also have tools to go through details such as regions, where you can mark on an image or on a text some specific regions and add some annotations or comment or description about these regions. And for moving image and audio files, we will implement a transcription tool where you can transcript specific sequences of these files, add descriptions, add annotations, comment, and link this resource to other resources as well. Sharing your data and your search queries with your project collaborators is also essential to have. So for that, we will implement an exporting tool to export the search results in different formats, such as CSV, XML, or JSON. And it will be also possible to store and share a selection of specific resources or the search queries. And another very important feature is to be able to compare two resources or more resources. So the user will be able to select interesting resources to display them side by side on one window and to work on all of them at once. So to have a great overview and to be able to edit and to work on each resource. So we still need to implement some missing feature. It's still in development, but we are on good track to go live in February 2021. We have currently more than 40 Swiss projects waiting to use this DaSCH service platform app. And currently, as André said, we have around 20 projects where the data are stored in our database. So we wanted to use open source tools, and of course our code is open access and open source on our GitHub account, so you can check out our GitHub account. And if you want more information about him and our work, you can check our official website. And we thank you very much for your attention.
Let's join in thanking André and Flavie very much for their comprehensive presentation. That's wonderful. Thank you very much. So thank you very much for joining, and see you later, hopefully. Bye-bye for now.